Hello everyone, in this video I'll be explaining you the problem Stone Game 2. Let's read out the problem. Alice and Bob continue their game with piles of stone. There are a number of piles arranged in a row, and each pile has a positive integer number of stones, piles of 5. The objective of the game is to end with the most stones. Alice and Bob takes turn with Alice starting first. So Alice is since she's lady, so ladies first. So jokes apart. So on each player's turn, that player can take all the stones in the first x remaining piles, okay, where x is basically from 1 to 2m. Then we set m is equal to max of m comma x. Initially m is equal to 1. So don't worry what all this, I'll be explaining you. The game continues until all the stones have been taken. Assuming Alice and Bob plays optimally, return the maximum number of stones Alice can get. Okay, the maximum number of stones Alice can get, we should return. So we have examples 27944. Okay, so let's go to iPad and understand what is the problem statement. So we have Stone Game 2. Okay, in this game there are two players. There are two players, Alice and Bob. So Alice is gonna start game first. Start game, okay? She's gonna start game, meaning she is gonna play first. So we have given stones array, okay, wherein the elements are, let's say, A1, A2 up to so on, AN, denoting length of this array is n. So let's say player is standing at index I, okay. So when a player is standing at index, either maybe Alice or Bob, so how many stones he can take? He can take first x stones, okay. He can take first x stones, meaning let's say in this array, since Alice starting first, he can take first x stones. So if you want to take concrete, what is x? X will have a value from 1 to 2m. And what is m? M initially will have value of 1. So uh, if you see Alice, how many stones she can take? She can take either 1 or she can take 2 stones, because when x is 1, she's going to take 1 stone. And since initial m is 1, so x will have a value of either 1 comma 2. So 1 means she's going to take 1 stone, 2 means she's going to take both the stones. Okay, and once x value is chosen and she takes a number of stones, so your m is going to update with maximum of m comma x. Okay, so how do you solve this problem? It's a directly you can think of in a recursive way. First Alice will gonna, I mean, she'll start first. So initially we know m is 1, so x will have a value 1 comma 2. So which means Alice can choose a value a1 or she can choose a value a2. Okay, when she chooses a value a1, so in that case your m is going to update with maximum of m comma x. Since m is 1, x is also 1, because 1 in this case x is 1 and in this case x is 2, so remains 1. So now Bob is gonna choose uh, depending on m value, he can choose no a2 or a2 comma i3. You're understanding, right? So we have an array, this thing. So since Alice has chosen just one value, so Bob will have a capability of choosing either just a1 or he may choose a2, because m value is 1. So you can choose x values which is from 2 star m. Since m is 1, so you can choose either 1 stone or 2 stone. When when Alice is choosing 2 stones, in that case x is 2, right? So your m is going to update with maximum of m. Initially m is 1 comma x, which is 2. So your m will have a value of 2. Now Bob has the option to choose value of x, how many stones you can choose. 2 star m is giving you 4. So Bob can choose 1 stone, 2 stone, 3 stone, or 4 stone. So if I take array, so since first 2 stones are chosen by Alice, Bob can choose just 1 stone or 2 stones or 3 stones or 4 stones. Okay. Whenever they chooses a stones, this score is going to add to their values. Okay. I mean, Alice having score initially 0, Bob also having score initially 0. So both will be adding the pile values, number of piles, okay, piles of stones. They'll be adding to respective. So in this question, they what they've asked, we need to return um, maximum Alice score. And since both the player plays optimally, so Bob will also try to maximize its score. It also tries to maximize its score. So both will play optimally. So how can we proceed with this? Um, since there is a choice problem, and I think if you have watched my previous videos like Predict the Winner or Stone Game 1 or Stone Game 3, so you'd have figured it out it's a DP problem only. First we need to find recursive steps. So since in the array we are starting from first and we are moving from left to right. So what will be our base condition? So our base condition will be if this I is greater than or equals to n. Okay, why what is n? Length of the array is basically n. If it is greater than or equals to n, so we need to return a pair 0 comma 0. So what is y pair? In this pair, the first value will be Ali's score and the second value will be Bob's score. Okay, since we don't have any element to choose, so both the scores will be 0 in that case. Now we'll call a a helper function or something like that. So let's take helper function. So it will have I value, it will have m value, and it will have turn value, like whose turn it is. Okay, if turn is true, then we can say it is Ali's turn. If turn is false, we can say Bob's turn, and then we'll pass a piles, vector, and we'll return the pair of int comma int. So first thing, base case we'll have to check. Then what we'll be doing based on turn, if turn is equal to true, if turn is true, then what? It's Alice turn. I'll be writing code for Alice turn, so similarly we can follow for the Bob's turn. So since if it is Alice turn, so how many stones he can choose? He can choose stones from you know from 1 to 2m. This many stones you can choose, and m is coming from this function. So what we'll do is initially we'll choose just one stone, then we'll choose two stone, then we'll choose three stone, up to 2m stones. So we'll have a value wherein we'll call a helper function. Okay, and when we are choosing one stone, so When we're choosing one stone, the next stone that Alice will be choosing is from I plus X. Okay, let's say I starting from 0. So he have chosen 0th stone. The next stone Bob is gonna choose from A1. Okay, so here 0 plus 1 is 1, so it is correct. Now your m value is gonna be, as we know, max of m comma x, and then this turn is gonna flip its value. If it is true, then it is going to send false. If it is false, then it is going to send true. So since it's a Alice turn, so it is always false. So you are flipping, and then we are passing this. Initially, we'll take score variable. Initially, score will be 0. So once we have chosen the first value and called the helper function, which means recursive function, what it's going to do is in the score we are adding the piles of I, whatever value we have I plus x minus 1 we're going to do. So it's like one value when it is choosing, I mean one pile when it is choosing. So in the score we're adding just one value. Okay, when x value is 2, since score already has a first value and it will choose second value wherein x will be 2. Okay, and this value is gonna be pair of int comma int, and we'll take one more variable, we'll say answer. Okay, so we'll have to check if your answer dot first, which means the score of Alice, if it is less than the whatever in the recursive function we have got. Okay, this is a recursive function, whatever score we have got plus the current chosen number of rows. If that's the case, then if this is not optimal solution, then we'll have to update the answer. It is going to be value, and in the answer dot first you're going to add this score. Okay. So this is it, and similarly we'll have to do it for the else case, which is like Bob's case. When turn is false, it is Bob's case. Same thing we'll have to do. Just that in case of first, here it will be answer dot second, because Bob's score is in second, and then we have to return the answer. And who are calling its function, like in the main function it is calling helper, right? So we need to return in the main function. Okay. You have to return this helper dot first, because we have to return the Alice score. So I think you have understood the algorithm, so how we are doing. I went a bit of fast in this video because we've already made two videos on stone 1 and stone 3. So if you watch those two videos, definitely it will be a just a quick video. Here the main thing is simply the for loop that we're using here, right? And it may happen that we need to check a condition wherein see I plus x minus 1, whatever we are doing here, this it may go array auto bound. So before doing this, we have to check if your this thing I plus x minus 1 is less than n, then only we have to do it. If it is not, then definitely we'll have to break, which means let's say you are somewhere, your array size is let's say 10 and your I is somewhere 8. Okay, and your x value is 3. So it's like since array is 10, so you have 0 1 2 up to so on 8 9, this many elements, but you're trying to choose 3 elements starting from x, which is not possible. So this case we have to take. So if it is not possible, then x is equal to 4 will also not be possible, x is equal to 5 will also not be possible. So in that case we have to break. So this I'll be showing you in a code. So let's go to the VS Code and try to solve the problem. We'll take n and let's make it a global variable. Okay, and then we'll have to define pair of int comma int as PII. You'll have your ns files dot size and we'll call a helper function. Okay, and whatever helper function returns, we have to return the first value because Alice score is stored in first and Bob's score is stored in second. So your I starts from 0 and we'll say true because it's a Alice turn, or we can say 1 here, meaning m value starting 1, so m we are passing, and then we have to say true, which means we are passing the Alice turn first, then we are passing files. The return type of helper function will be pair of int comma int because we are storing two values here, Alice and Bob scores. So it is I and we have m and we can call boolean Aliston. It will make more sense. Aliston true means it's Aliston. If Aliston false means it is Bobston. Now base case whatever what did I say? If n is greater than equals to n, so we need to return uh, 0, 0, meaning since it is not able to take any pile of stones, so both Alice and Bob score will be 0. Now you have to check if Alice turn, which means it's Alice turn, else it will be a Bob's turn. We can call something like variable. Let's say here it will be answer. Answer will initialize the 0, 0. Okay, and we'll take int score. It will be also 0. So we'll call a function uh, recursively. What should I call? Further score or some. We'll take val. We'll calling a helper function. Before that, we need to check x, right? X will start from 1 and it is lesser than equals to 2 star m x plus plus. Okay, so how many stones we are choosing? That is the thing here. So let's say we have chosen one stone, so it will be I plus x, right? I x is 1, so we have Bob has to choose from I plus 1. If it is x is equal to 2, which is 2 stone we have chosen, so your next will be I plus 2, which is taken care by x variable, and your m is going to be max of m comma x. Okay, as said in the question. Here they have said, and your Alice turn is gonna flip its value. Since Alice is playing, now next Bob has to play, so we are flipping its value. Then we have piles. Okay. In your score, since we have already defined score, so in your score you have to add piles of I plus x minus 1 value. Since you can think of this way, um, when Alice is starting from 0th index and it is choosing just one stone, piles of stone. So in that case, you'll have to have a zero value. So I is 0, x is 1, so minus 1 you're doing here. Okay. So you've got a score. Now you need to check if answer dot first, which is the Alice score, is lesser than val dot first. So whatever you know from the further choosing elements, choosing the number of files, whatever score you have got, and you're adding the present score. If it is greater than the right now the maximum score, then you need to update the answer to val, and answer dot first will be score, because this whatever value you have got, you have both the scores, Bob's and scores, Bob's and Alice, and in the Alice score you have to add the present score as well. Okay, and since you are doing this thing, you'll have to check if I plus x minus 1 is lesser than n, then only you should be doing these operations, or else you're not allowed to, you will not be able to, choose the extra element. So in that case, we'll have to break. And the same thing goes with Bob as well. So I'm just copy pasting thing. And instead here of first, it has to be second because Bob's score is stored in second. Okay, right? And then when you are coming out of this if else, you need to return this answer. Now let's try to run it. It will be piles. Oh my bad. So it was giving Tilly. The reason I'll tell you. At max we have n is 100. So let's go to here. So if you try to analyze time complexity, what will happen is at max n is 100, and since we have an array, we have a1, a2, a3 up to so on n elements, and this element will either be chosen by Alice or it will be chosen by Bob. So it has a choice. So it's like 2% can choose. Similarly, this element can be chosen by 2%. Similarly, this can be chosen by 2%. So it will go till n times. So it will be 2 to the power n. And since n is 100, so you can do this. You can call 2 power 3 uh, 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 into 33 you can call. So 2 power 3 is 8. What I'm trying to show is basically 10 power how much it is gonna come. Okay, 2 power 10 is a huge number, like 2 power 10, sorry, 2 power 100. Um, okay, this way you can do. So 2 power 10 into 10 you can do, right? So 2 power 10 is 1024, and this 1024 can be written as 10 power 3000 into 10, so it will be 10 power 30. So it's much greater than 10 power 8, so it is going to give you TLE. So we need to optimize this. In order to optimize, we'll have to use TP. So we'll have to maintain states. uh, okay, so in order to maintain states, you can check what variables are changing. I is changing, M is changing, and this Alice turn variable it is changing. So these three variables are changing, so we have to maintain a 3D TP of pair of int comma int, because two states we are maintaining. So I can go value from 0 to n minus 1. So we'll have to take n. And m can go value, how much it can go? This is a trick. So m, how much it can go? So m, let's say it depends on I, right? Where you have. So let's say at max your n is 100. So you have 100 element array, A0, A1 up to so on, A98, A99. So let's say you're standing here. So when you're standing here, so how many elements you can take? M is so I is 99, but n m I mean from here it can choose at max how many elements. Ideally, I mean actually you can choose just one element, but ideally it has the capability of choosing up till m elements. Okay, so you can think of double of the array size it can take, because your x value is from 1 till 2 star m. Okay, so somewhere let's say the element chosen, or I mean in the previous step, let's say n minus 1 element are chosen. Okay, n minus 1 element are chosen. So in that case, m is like m minus 1, right? So it will be 2 into n minus 1. So n minus 1 you can remove it, you can say 2 into n. So m can have a at max value of 2n. That I'm trying to say. Okay, so so at max it can have 2m, 2n plus 1, because 2n, if we want to store on 0 based indexing, it has to be 2n plus 1. And we have vector parent comma int, and this boolean variable Aliston can have true or false value, which can be denoted in 0 1 variable, so just 2. And both Alice and score, I mean Bob score, has to be initialized with -1. Now we'll have to pass this into a function. Okay, now here also we'll have to pass, and then here also we'll have to pass. And before returning the answer, we'll have to store it in a variable dp. And when you're computing, before computing, we'll have to check if the state is already visited. If it is already visited, then we'll have to simply return the answer. You don't need to again calculate it. Okay, now let's try to take the time limit exist test case and try to run. So it is running fine. Let's try to submit it. So yeah, you got accepted. So in this way, you could have easily solve the problem. And if you do want to analyze time complexity, now it will be a n square. Because we're maintaining states, so it will be n square solution. So yeah, thank you guys.